Why are airplane wings filled with fuel? 99% of people don't know the real reason. Have you ever looked out of an airplane window and wondered what is actually inside those enormous wings? Most people assume they're just made of metal, wiring, and mechanical parts. But the truth is far more surprising. Inside the wings of almost every large commercial aircraft is something that keeps the entire airplane alive. Thousands of gallons of jet fuel. It sounds strange at first. Why would engineers store highly flammable fuel inside the wings instead of the main body of the aircraft? Wouldn't that be dangerous? Why not place the fuel closer to the engines or inside the fuselage where it seems safer? The answer is a fascinating combination of physics, engineering, safety, and efficiency. In fact, the reason has nothing to do with convenience alone. Every drop of fuel inside an airplane's wings plays a critical role in helping the aircraft fly safely across oceans, survive turbulence, and carry hundreds of passengers over thousands of miles. To understand why, let's first think about the enormous forces acting on an airplane during flight. A fully loaded passenger jet like the Boeing 777 or Airbus A350 can weigh more than 300 tons during takeoff. As the aircraft accelerates down the runway, the wings begin generating lift, the upward force that allows the airplane to leave the ground. But here's something many people don't realize: the wings don't stay perfectly straight. As the airplane climbs higher, the lift generated by the wings is so powerful that they actually bend upward. On some aircraft, the wingtips can flex several meters during turbulence or takeoff. This bending is completely normal and is carefully planned by engineers. Now imagine if those wings were completely empty. Without any weight inside them, the upward bending force would become much greater, placing enormous stress on the wing structure. Over thousands of flights, that extra stress would shorten the aircraft's lifespan and require even stronger and much heavier construction. That's where fuel changes everything. Instead of carrying all the fuel inside the fuselage, engineers store it directly inside the wings. The fuel acts like a perfectly positioned counterweight. While aerodynamic lift pulls the wings upward, the weight of the fuel gently pulls them downward. These opposing forces balance each other, dramatically reducing structural stress. In simple terms, the fuel isn't just powering the engines, it's also helping protect the wings themselves. But structural strength is only one piece of the puzzle. There's another reason that's even more important: balance. Every aircraft has something called the center of gravity. Think of it as the exact point where the airplane's weight is perfectly balanced. If that balance shifts too far forward or too far backward, flying becomes much more difficult, and in extreme cases, even dangerous large passenger aircraft burn thousands of gallons of fuel during long flights. If all that fuel were stored in one central location, the airplane's balance would constantly change as fuel was consumed. By spreading fuel across both wings, engineers keep the aircraft balanced throughout the flight. The fuel management system automatically transfers fuel between different tanks whenever necessary, ensuring that both wings remain nearly equal in weight. This balanced design gives pilots better control, improves stability, and reduces unnecessary strain on the aircraft structure. There's another advantage that most passengers never think about: space modern. Long-haul aircraft can carry well over 100,000 liters of fuel. Finding room for that much fuel inside the passenger cabin or cargo section would be nearly impossible without sacrificing seats or cargo capacity. Fortunately, the wings already contain large hollow spaces created by their internal support structure. Instead of wasting this valuable volume, engineers transform the inside of the wings into giant fuel tanks known as integral fuel tanks, or wet wings. This design allows airlines to maximize passenger space while carrying enough fuel to fly across entire oceans without stopping. Every inch of the aircraft is designed with efficiency in mind. Nothing is wasted. The benefits don't stop there. Another surprising reason fuel is stored inside the wings is to reduce stress on the aircraft's landing gear. During takeoff, the airplane is at its heaviest because the fuel tanks are completely full. Since much of that weight is distributed inside the wings instead of concentrated in the fuselage, the load is spread more evenly across the entire airframe. This balanced weight distribution reduces structural stress and helps the aircraft handle enormous loads safely. As the flight continues and fuel is burned, the airplane gradually becomes lighter. A lighter aircraft requires less lift, consumes less fuel, and becomes even more efficient. This is one of the reasons why long-haul flights become more fuel efficient as they progress. But what happens when the engines need fuel? Many people imagine the fuel simply flows straight from the wings into the engines. In reality, the system is far more sophisticated. Inside the aircraft are multiple fuel tanks, powerful electric boost pumps, backup pumps, filters, valves, pressure sensors, and an advanced computer-controlled fuel management system. Every second of the flight, this system monitors how much fuel remains in each tank, balances the weight between the left and right wings, and delivers exactly the amount of fuel each engine requires. Even if one pump fails, backup systems immediately take over. Commercial aircraft are designed with multiple layers of redundancy because safety is always the highest priority. Now, here's something that surprises many people. If airplane wings are full of fuel, why don't they explode when struck by lightning? The answer lies in decades of engineering and testing. Commercial aircraft are struck by lightning more often than most people realize. On average, a passenger airplane is hit by lightning about once every year. Yet accidents caused by lightning are extremely rare. That's because the aircraft acts like a giant protective shell. When lightning strikes, the electrical current travels along the aircraft's conductive outer skin and exits from another point, usually without affecting the passengers or critical systems inside. The fuel tanks receive special protection as well. Engineers use conductive materials, bonding straps, lightning protection systems, and carefully sealed fuel tank designs to prevent electrical sparks from forming inside the tanks. Since jet fuel itself is difficult to ignite without the correct fuel-air mixture and an ignition source, the risk is far lower than most people imagine. Before any commercial aircraft is certified to carry passengers, manufacturers perform years of structural testing, fuel system testing, lightning simulations, pressure testing, vibration testing, and extreme environmental testing to ensure the aircraft remains safe under real-world conditions. Here's another interesting fact. Have you ever noticed small openings underneath airplane wings while boarding? Some passengers mistakenly believe they're leaks. They're not. These are carefully designed fuel vents. As fuel is consumed during flight, air must enter the tanks to replace the lost volume. Without proper venting, a vacuum could form inside the tanks, making it difficult for fuel to flow smoothly to the engines. The vent system keeps the internal pressure stable throughout the flight. On very long flights, another fascinating process takes place. Modern airliners constantly calculate the aircraft's balance. Some wide-body aircraft even transfer fuel between different tanks automatically during flight to maintain the ideal center of gravity. Keeping the aircraft perfectly balanced reduces drag, improves fuel efficiency, and saves airlines thousands of dollars over the life of the airplane. When multiplied across thousands of flights every year, even a 1% improvement in efficiency translates into millions of dollars in savings. That's why every detail matters. The location of the fuel isn't just about storage, it's part of an incredibly complex engineering system that improves strength, balance, efficiency, range, and safety, all at the same time. So the next time you sit beside an airplane window and look out at the massive wings, remember that they are much more than structures that keep the aircraft in the air. They're also giant, carefully engineered fuel tanks, balancing hundreds of tons of weight, protecting the aircraft from extreme forces, supplying the engines with a constant flow of fuel, and making it possible for modern airplanes to fly safely across continents and oceans. What looks like a simple wing is actually one of the most remarkable engineering achievements ever created. And that's why the fuel is stored inside the wings, not because engineers had extra space, but because it's the smartest, safest, and most efficient design ever developed for modern aviation.